back. I'll be talking about some secrets of the KQL. Yes, the picture and the person is myself. It's been like almost 2 to 3 years before I taken. I've had so many people ask me to change the picture as because I don't look like that, but that is me. Trust me. So I'll be talking about the Kusta query language by itself. Let me give a short introduction from myself before I start about it. Um, who am I? What is a slide or a presentation without the who am I slide? I'm a senior cybersecurity engineer. I work in Defend in New Zealand with a cybersecurity firm. I started as a security operations engineer. We do incident response as a SOC team. I've been doing that for 2-3 years roughly. While I was doing that, I also slowly started moving into the SOAR components where it's the automations and integrations because the advanced attacks has been growing up over and over and over again that it's not doable just by manual work. So that's where the SOAR components come in. For people who are unaware, SIEM is the security information event management. SOAR is the security orchestration, automation, and response. I mainly focus around the Microsoft Sentinel and M365 Defender. So anything around the Microsoft suite is what I've been working on mostly. I recently moved into the engineering team where I support the operations team for building any kind of an automations, or do they need to collect some logs from one source platform to another destination platform, which is Sentinel most of the time. So we built a couple of integrations. We've contributed to the community back to Sentinel, published it as a free solution as well. We'll be talking about those in soon as well. So that's a bit of an introduction about me. Without further ado, before we get into the language Kusta query language by itself, what I would like to address is there are two different types of languages in SIEM that I would like to categorize as. One would be the event-based language, and the second is the query-based language. The difference is that event-based languages they're primarily focused on matching a pattern, whereas looking at a specific IOC or a specific signature, and it's very much useful when you look into a memory dump or a file or a binary analysis, and it's very commonly seen to be used in malware analysis as well. There are a few SIEM solutions that contribute event-based languages as well, but it might not be the best kind of the language to be used for a SIEM solution by itself. The reason why is defines the query-based language, which is primarily focused on the log aggregation, correlation, and the analysis. So it's not going to be just one single file that you're going to look into and see, cool, is this a bad thing or is this a good thing? Instead, you're going to be looking at heaps and heaps of logs coming through there, saying that there's like a bunch of events. I want to see a specific behavior. It's not just about an IOC match. It's not just like a find and replace or look for a specific signature. It has to be a behavior where there's 10 different failures, out of which after the 10 failures, there's one successful sign-in. That kind of a multiple event lookup is where the query-based language comes in. Key use cases, I would say, is log analysis, where the whole point of SIEM solutions come into play. So my preference would be to have most of the SIEM solutions use the query-based language for having the capability to work with different kinds of tools and platforms. Actually, there's a few languages running around in the SIEM world. I wanted to stress something and bit of a brag about KQL by itself. KQL, Kusta Query Language, is a native language that is used by Microsoft Sentinel. There's a few other in the wild. XQL is used by Cortex XDR. EQL is used by Elasticsearch. SPL is used by Splunk. AQL, Aerial Query Language, was used by IBM QRadar, which recently adapted KQL as their native query language as well. So they have addressed an article where they said the capabilities of the Kusta query language is pretty amazing, and they had to adapt their platform to use a different vendor's query language into their, which is pretty amazing, I would say. And then there's the old school Yara. Yara L is a bit new from Google, which is used in Google Chronicle, and Sigma. Yara and Sigma are open source languages that's been used across multiple SIEM solutions as well. So these are some of the commonly seen languages in the SIEM world. So jumping into Kusta query language, the first question I always wanted to understand was, what is Kusto? What does even mean about it? So apparently there is a name origin about it, and it's coming from a TV show, The Undersea World of Jacques Cousteau. I had a book, Must Learn KQL Security, written by Rod Trent. He's an amazing Microsoft expert who's been working around Azure, OpenAI, KQL, Copilot for security, and all cool stuff in there. And he mentioned that it's a deep sea divers TV show. His name was Jacques Cousteau, and quote is, we are exploring the depths of our data. We are attempting to surface the critical and necessary security information that will tell us about the potential exposure through simple, powerful queries, which is almost equivalent to how deep sea divers go down, find the specific cute little things and stuff like that. So that was the comparison and the name origin of where the word Cousteau came from, which is very interesting. And I thought I would share it to you guys before we jump into this whole thing. The language by itself, as an overview, it's a very simple language. It's very easy to read and understand. It is a read-only request language, as in anything that you run or use the language is only going to be a read-only thing. You cannot write back something to your logs or the database using the language by itself. As mentioned earlier, it's very expressive, and most of the you'll be seeing in some of the examples I'll be showing down there. It's pretty self-explanatory when you see the name of the operators and the syntax that it works on that. So that's a quick overview of the language. I'll start with basic to intermediate to the advanced part of it. Yes, I did promise it's a secrets of KQL, but I want to start from the scratch so that people can follow up on that as well. For every single query language, yes, you'll be having some of the basic operators, such as the logical operators and relational operators. So if you want to check a specific condition saying that did the user log in from IP address that is outside New Zealand, as well as did they log into an application which is not an Outlook. So you want to do an AND condition on that. So AND conditions or condition is either of one condition satisfies. I don't care if both satisfy at the same time. Not is a condition where it's an opposite of whatever the condition that you're requesting in that space. Pretty standard, pretty basic. Yes, of course, every language supports, and KQL does support the logical operators as well. Relational operators, if you have any kind of numbers or some kind of a metric that you want to measure against, saying that is there any sign-ins, more than 10 failed sign-ins, or is there any activity that has been 100 gigabytes of data whatsoever. So if you want to have like greater than, lesser than, exact equal to, greater than equal to, less than equal to, not equal to, those kind of stuff will be handled by the relational operators. It will be used mainly for integer type of the data, like the numeric data in that space. Next would be the where operator. People who are familiar with the SQL language, you might recognize this similar to the select operator, where you have a bunch of a column with multiple values, and you're looking for a specific column in a value in there. In my example, I can see that sign-in logs where if the IP address contains 1.1.1.1. Seems like I missed a typo on that one, regardless. But I know which column I'm looking at. So that's where I would use that is when I would use the operator where, when I know where I'm looking at. The second operator, search, in that case is, let's say I know I want to look for an IP address, but I'm not sure where I need to look at. It could be in IP address column. It could be in IP address details column. It could be in a different column, which is the column name that I'm not familiar with. I want to search it across the entire table. In that case, I would use the operator as search, which is very handy as well. When you jump into I've had some experiences where I jump into a table to do some threat hunting, and I'm not familiar with the type of the logs that I'm dealing with, and I'm not sure where exactly I need to look at. I would just do a whole search, which looks into every single columns in that specific table. Of course, it's a bit resource consuming, and it takes a bit more than time than a narrowed search of looking into a where operator. KQL supports both, which is pretty cool in that space. Nextly, string operators. Of course, we're dealing with logs, and we would be dealing with characters, strings, and seeing how do we match those characters and what are the types of the operators that are really cool. There's heaps of it, but I'm going to be covering the basics and the key things that you'll be encountering on a day-to-day basis. Contains is an operator where if a part of the word literally contains the word that you're requesting, it's going to give you a match in that way. For example, the word computer contains the word put. Same way, has is something you have, it's similar to contains, but it has to have the whole match rather than just a part of it. So the word computer has the word computer as the whole word by itself. The next operator starts with is when it's just a part of it. So the word the operator contains would also satisfy it, but you are explicitly saying that the word should start with that specific set of characters. So the word computer, seems like I haven't edited that. I made some typo in that space. Sorry about that. But the word computer starts with the word starts with the word com. Same way the word computer ends with the word ter. So these are really cool when you want to do some kind of a search on your text to see what's good, what's bad in that space. Obviously, what you also can do is if you add underscore CS at the end of each operator, it becomes case sensitive as well. And if you put an exclamation at the start of the operator, it becomes a negative operation of that space. So that's a pretty cool thing that I've been using in every day-to-day operations as well. Second set of string operators, there's a few, because has any, has all, which is more of like you have a list of characters that you want to look at, list of words that you want to look at. So say, for example, test 1, test 2, test 3, test 4. And you want to see if the words test 2 or test 5 are in the list 1, 2, 3, and 4. Yes, it would satisfy because test 2 is part of that thing. So even if one of the words satisfy the condition, that's has any. Let's say you want to have has all, where you want to look into both has to satisfy the condition. For example, test 2 and test 5 needs to be in the list that you're giving. So test 1, 2, 3, and 4 will not satisfy the requirement because 5 is not part of that list. So that's the difference between has any and has all. The next one would be matches rejects. I'm a big fan of regex. Some people might hate it, but I'm guilty of that. It's really, really cool thing to use regex, especially when you're doing in security operations and you're not sure what you're exactly looking for. Regex is a really cool thing for you to handle some logs and do some correlation. Let's say I'm not familiar with what are the numbers on the list. There's test 1, 2, 3, and 4. I'm not sure what are the numbers on the list are there, but I want to filter that list. I can just go test dot start. That would mean anything that's after test, whatever is it. If it matches it, give me the whole list of that. So there's 1, 2, 3, and 4. It gives you the whole list of the words that has those specific matches in that space. The next one, extract all, is very similar to the matches rejects, but what it's going to do is you can extract just the value that is getting matched against instead of the whole word by itself. So instead of getting test 1, test 2, test 3, test 4, I'm just going to get the 1, 2, 3, and 4, the values that are getting matched on the regex. It's enclosed by a parenthesis that, as you can see on the brackets at the end, which will pull those values for you on that space. Has been handy very, very much as well. KQL's capability is really helpful when it comes to incident response with this space. One of my favorites is the graph operators, which is something I never knew when I started with the whole KQL. I thought graphs is something that you need to go outside of the KQL, like a query language, to generate some kind of visualization. But luckily, KQL has the capability to generate some visual representation as well. So all I need to do, let's say you have a bunch of different numbers. Instead of just saying that New Zealand has 1,000 logins, Japan has 500 logins, United States has 200 logins, or whatsoever, for me to manually calculate the percentages of it, all I can do is just do render pie chart, and it will automatically give me a visual graph of that, and it would give me the number of the percentage that's going to do that. So, which is very handy for two reasons. One, for me to visualize the number for myself, to calculate the percentage to see what's higher, what's lower. Two, when I want to generate some reports for board members or chief executives, this comes in very handy for me to show as a pictorial representation rather than giving some raw logs and numbers and stuff. So that's pretty cool as well. The second graph operator that I'm really big fan of is the time chart. I've had heaps of scenarios where we wanted to see activity, where what is the volume of the activity? Is it higher at this time or is it lower at this point? And it gives us pretty cool graph that you can draw to see that. Example graph on the diagram, on the screenshot that you can see here is on the August 1, 2, and 3, you have high spike of volume in there. But 4, 5, and 6, you can see that the volume is very, very less. And it helps you immediately find out that, cool, the volume is very less around August 4, 5, and 6. The reason is because August 4, 5, and 6 of the last year was Saturday, Sunday, Friday, Saturday, Sunday. So obviously the volume would be lesser at this period of time, which makes much more sense. So these kind of a visualization factor helps us in SIEM solutions. And whenever there's an incident, to see what's the highest volume, lowest volume, what's good, what is the anomaly in that space, those kind of stuff. Apart from the pie chart and time chart, There are still heaps and heaps of other kind of charts. I think there's like line chart, there's bar chart, there's column chart, there's tree maps and everything else, which is very cool as well. But I wanted to stress these two specifically for this presentation. So we've already come up out of the normal basic operators, apart from just string search or looking for a specific IOC, to representing like a diagram or a visualization capabilities, which is something that not many people are aware of the language by itself. Let's move a little bit more advanced. Before we get into the actual functions, I want to say what is the difference between an operator versus a function. So operators are like the preliminary capabilities in the language, and functions are a set of operators packed together, written as a code, and has been given to solve complex problems to use using a simple syntax. I like to call functions as basically an operator, but with some superpowers, so it makes it easier for us to understand as well. There are built-in functions from Microsoft by themselves, which is most of the solutions will be justified with those functions. But if, let's say, you need to write your own function for a specific scenario, you can still use your user-defined functions as well. Some of the functions, people who already work on programming or development, you would see that if condition, switch cases will be handled as well. So if you want to write, if the severity is higher, so if the login is coming from New Zealand, I want you to put a severity as low. But anything that's outside New Zealand, I want to put it as high. You don't even have to go for a specific automation or something to do that condition. You can write it directly on your query language by itself. Same way, let's say if it's not like an if and else condition, it's more than one condition, like a switch case. The location is from New Zealand, I want to put it as low. If the location is from Australia, I want to put it as medium. If it's anything else, I want to put it as high. So those kind of multiple conditions, yes, you can do that on switch case as well. That is pretty cool, and I've noticed that as a very handy thing to use during times of writing detection rules as well. Another thing I've noticed is you can create MD5 and SHA-256 hashes directly on your code. So you have some kind of a file or a log analysis, like a text of whatsoever, or an email address for which you need to create a hash. You don't need to go there, online hash generator whatsoever. The language by itself has the capability to do it on the fly as well, which is a really handy capability as well. Some of the date time functions, pretty standard. You might see in other languages as well. Ago is where you want to see for the last 5 hours. Instead of specifying, again, now the time is 5 p.m., I want it from 12 p.m. or whatsoever. Instead of explicitly mentioning the time, you could say before the last 5 hours or whatsoever from the current time, it automatically do that. Same with for date time difference. You have current time versus the old time, and you can just do a difference between that, and it's going to give you in hours or days or seconds, however you want it in that space. My favorite data function, the last two, is the UTC to local and local to UTC. On the fly, you don't even have to calculate it outside it, but the operators by itself will translate a UTC timestamp to a local timestamp. Whatever you have is your local time zone mentioned. Same way, if you have a local time zone, but you want to put it on UTC, you can do that as well, directly on the query language. So again, you don't have to get outside your query to do all these kind of magics, which is something pretty cool. Getting into the advanced functions, some of my favorites. First one is to create a GUID. I swear I used to create, every time I need a GUID, like a unique identifier, I always go to a free online GUID generator to create one so that I can use it for a specific alert assigned to it. But with KQL, you can natively create a GUID on the fly on the query by itself by using the operator new _ GUID. Like I said, most of these keywords, most of the operators and functions you see there, it's very expressive. You don't even have to Google them or like trying to understand what they exactly do. It's self-explanatory. The second operator is parse URL. There's number of times that I've struggled with when I have a long URL where I say which one is the domain, which is a subdomain, which is a port, which is the path of it, what is the specific parameters that's being passed into it. Instead of me decoding it manually, the query by itself has an operator called parse URL. I just put in that, extend the result, and give me parse URL of that specific URL. So for example, I have a test domain of port 8080, malicious file download, user equal to test, key equal to 1 to 3, blah, blah, blah. And when I pass it on the KQL query, when the alert gets created by itself, it breaks it down for me as the fragment, the host, if there's any password on the URL, what is the path of it, what is the port in there, it automatically breaks that URL for me and gives it in a structured way for me to, from a incident response perspective. It's more good enough from a readability perspective and makes it easier for me for the investigation. basics for encoding and URL encoding, which is, again, I used to do it outside on an online generator or online encoder decoder kind of stuff. But whenever I see a basic for decoder value, I can do it directly on the code by itself on the fly instead of taking it externally, so that the data doesn't leave the Log Analytics Workspace. So you have a long URL down there, which has URL encoded values in there. Sometimes the logs that you get from different platforms might be coming with a URL encoded value, which is hard to read sometimes with this %2f, blah, 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 stuff like that. But you can automatically decode it. And if you see the result on the bottom below, you can see that it has the learn.microsoft.com/en-us. Everything has been decoded for you in that space. Same way, we could do that for basics for encoding and decoding as well. My favorite of all of it is something I learned very recently. To be honest, I didn't even know this existed for a while. Geo info from IP address. KQL or a query language is supposed to be playing with or like to work on the logs or information that is in the database and nothing that's outside from it. Anything that is outside has to be like from a specific automation that you go reach out, get the information, enrich it, whatsoever. But the query has a capability to do that for you automatically, to collect an information about an IP address, the city, country, latitude, longitude register, and the state of that specific IP address. This is kind of like solving a SOAR problem directly from your KQL query. So you don't even have to build a dedicated automation to do that. Instead, earlier you need to do like a dedicated API call, do an IP repetition checker, get the location of the detail, blah, 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 stuff like that. But you can do that directly on your KQL query, which is pretty mind-blowing from what I've seen as well. That's mostly from the advanced functions part. One last thing I want to stress about is there's something called as plugin, which is the highest in the hierarchy. I would say that operators, functions, and at the topmost sits the plugins. There's heaps and heaps of plugins, different types of plugins, general plugins, reshaping plugins to manipulate your data, language plugins, which is pretty amazing, where you can literally run a Python script inside your KQL query, where you can do almost anything, to be honest. You can't download packages and stuff, but all the minimal scripts that you can do should be run. And there's another one called connectivity plugin, where you can make an API call from your query. It's not just for that IP address that we spoke about, but if you have your own API endpoint or whatsoever, you make an API call, you can have authentication, authorization, whatsoever on the KQL query by itself, and that query will give you a response back, and that response could be parsed down, do some operation. Again, these are not done by any kind of an automation, but it's done directly on the query language by itself, which is a scene component. Last but not least, what I would do as a success metric for a scene and a SOAR solution is that if you have to solve a scene problem using a SOAR component as a basic problem, but using an automation or a dedicated integration that you have to build, it's really not so good. But if you are solving your own scene problems using scene components and your SOAR with your SOAR components, that's good enough. But the way I see with KQL and Microsoft Sentinel is that you are solving the SOAR problem, which is an automation requirement. It's bringing the automation capability using a scene component by itself. That's pretty mind-blowing from what I can see. So that's one of the reasons why I would say KQL is really, really amazing, and not many people know about these plugins and functions, which is what I wanted to bring it to everyone's attention, and hope that's going to be useful moving forward as well. I see I'm already on time, so
that was awesome. Thank you so much, mate. I actually didn't realize that KQL is so powerful. I know about it, that you could use it with to query your data, and it's super cool, but you have taken it to the next level. So my question is that if someone wanted to use this tool or like learn more about it, what would they use? What do you recommend for them to actually go and read?
There's heaps of online materials around it. I believe there's Microsoft Learn materials, but the first, as a starter, I would say, is there's a must-learn KQL book. It's available free on online PDF on GitHub as well, or you can buy it on Amazon for like $10 or whatsoever. It's by Rod Trent. It's really, really amazing. If you're familiar with the basics, you can also go to the second version of the book, which is Get Advanced KQL version, which is really good. If you already have a Sentinel or a Log Analytics Workspace instance, there is an interactive workbook through which you can learn KQL as well, saying that, cool, this is what you're seeing, you can run this query and you can do this, blah, 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 all this kind of stuff. So that's a really good start. So I would start with online materials, and then like a book, maybe if you want to go with the PDF or the soft copy or the hard copy, or you can go with the interactive version on the workbook by itself to play with KQL with live data.
Nice. That's great. Thank you so much, mate. That's so much. Very interesting presentation, and thank you for joining us. Really interesting
Awesome.
topic.
Cool. Thank you.
Thank you.